Hey everybody, welcome to another deep dive. Super excited today. I have with me Albert from
Hey Nick, how's it
from
going?
Genlayer. It's going great. Yeah, no, super excited for this one. Um, I had kind of been watching a lot of your videos over the past week, and I'm excited about this one. But I would love to ask, like you actually, how did you get into an AI blockchain? Because like you have a long history in the space, I would say.
Mhm. I've been in the space since 2013. I've been on multiple L1s like NEM and Radix. I've been doing everything from consultancy, trying to sell, Ethereum technology like smart contracts to companies and governments. And like I've been really looking at pretty much everything that you can do in crypto, from DeFi to whatever you want, really. Eventually, what I've seen over the last few years is that it's kind of becoming a bit, stagnant. I think it's like everything has become super complex. There's a huge suspension of disbelief in like what is acceptable or not. But like decentralization doesn't matter anymore. Trustlessness doesn't matter anymore. Everything is just like trying to make the quick buck, right? And that is something that to me is pretty sad. I think that we need to find a way to kind of like go back to the roots and try to find how to actually make trustless systems again. And so one of the things that I think blockchains have been missing is the capability to connect to the internet. I think what you guys are doing at Teller is very interesting, which is how do you connect a smart contract to the outside world, right? And there's kind of two different approaches. One would be let's specialize on price data, for example, which as you were saying before, like has very specific APIs. You need to make sure that the quality of the data is very high, right? And then like just make sure that it goes into the smart contracts as fast and as correctly as possible. But at the same time, there's a bunch of other use cases that have nothing to do with that, right? That we just need, for example, for the smart contract to be able to connect to the internet, and right now it just can't, right? I don't know. Let's say digital identity, right? You would maybe want to just sign a transaction, post it on Twitter, and have the smart contract go check it out, right? That is not possible just because the Oracle infrastructure is very focused on having, like specific data feeds and like just very much streamlining the processing of the data, right? What we're doing is we're basically using AI at the kind of consensus level in order to enable use cases that basically have, a smart contract that can natively connect to the internet or a smart contract that can process natural language in order to make subjective decisions, right? It's like if you look at blockchains, there's 1,000 blockchains out there, but really like the type of features that they have is basically the same, right? It can be faster and cheaper, but like, you have the same type of deterministic logic and you can do the same regardless if we're talking Cosmos, Ethereum, Solana, doesn't really matter. What we're saying is, hey, can we essentially unlock new types of applications by having let's say another type of consensus algorithm that instead of being static is dynamic, right? And it's a very big shift in terms of how we can do things, to be honest. So
Yeah. No, I have a million questions on kind of how that would work and just the history of it, but I guess, do you think you could just summarize? I think it's actually relatively simple how it actually works. Like you have some validators and they
yeah,
report data.
you can think about like how do humans like coordinate and reach consensus, right? Yes. So we're now essentially in the age of AI. Things are gonna go crazy, right? And well, we've discovered that these things called large language models can make decisions without human intervention, can basically create code, right? And they can even like loop around it, like making sure that you can have this thing called agents, which is capable of like asking the LLM to think and then plan and then execute and then kind of loop that, right? So in this world of AI, we need to understand that things are going to be changing, right? And that the existing frameworks don't really make sense for that, right? So if you think, for example, we've been part of a very like heavy litigation, takes years, it's very expensive, like lawyers and so on, right? Do you think that when everybody will have their own AI in their pocket, do you think that they will be dealing with each other through traditional law? Are they going to do it through smart contracts that can't connect to the internet and can't even understand natural language, right? We're essentially trying to propose a third way, right? Essentially a synthetic jurisdiction for AI commerce in a way like a trustless third party that is intelligent. I mean, we're calling it an intelligent blockchain. And I understand that it's kind of difficult to tell what makes sense or not in crypto. Like there's just so much stuff, right? What we're saying is here is a decentralized protocol that at the consensus level uses AI in order to make subjective decisions, right? So it's like the consensus was like this. There is basically 1,000 validators from each transaction. there's a subset of 5 selected at random. There's one of them that is selected as the leader. The leader makes a proposal, and then the other 4 essentially validate that proposal. So they need to say thumbs up, thumbs down, timeout, or I don't know. And then depending on that, the majority vote kind of like decides what's happening, right? So there's an appeal window. You can appeal that doubles the number of validators. Essentially, the idea is based on this thing called the Condorcet-Jury theorem, which is the wisdom of the crowd, right? It's like instead of having a single LLM giving you a single validator giving you an output, what you want is to aggregate the outputs of different LLMs, ideally, different validators, and then if they have different point of views, if they're independent, if they are correct enough, right, then you will get a better response than if you're just using one of them, right? Like all these hallucinations, biases, all the incorrect, these are stochastic models that can be wrong, right? How do you remove that incorrectness? How do you increase the correctness? How do you reduce the biases? And you do it by, instead of focusing on how do they think, you focus on what do they output and how you can compare what they respond.
So we'll draw, I guess, some validators here. So these would be like the validators, and let's say there's like 1,000 of them, right?
Right.
And then is this just token weighted proof of stake, or is this something?
It's a yes. I mean, it's a DPoS, right? Okay. So it's a delegated proof of stake. Each validator needs to have their own self stake. And then there's the delegated stake as well, right? So there's up to 1,000, anybody can do it. And then yes, it's weighted based on the self stake and the delegated stake, right? It's a logarithm of the both, and we're exactly trying to tune which is the best ratio for the type of reward that you should be getting, right? But essentially, it pushes towards the stake to be distributed across the validator set, right? And for, if you have a lot of stake, maybe you want to split it in multiple of them, like trying to make it so that there's basically 1,000 validators with as much self-stake as possible. And then the delegated stake as well is a mechanism to help anyone be able to be part of that, right? So, yeah.
Yeah, no, that's cool. And then, yeah, I mean, 1,000 is kind of big. That's a good number.
Well, I can show you. Look, I don't know if I can share. Are you okay if I share? Yeah, here.
Here, I gotta allow you. See? Yeah, no, go ahead and share.
All right. So we've got this small like simulator here, right? It kind of like helps you understand. Let me see if this works.
Well, I think it's also like, what block time are you guys going for?
Well, it's a bit of a different thing, right? So
sure.
Let me maybe take a step back. Let's see how I do this. First of all, if you look at the architecture of the system, right, it looks something like this, right? So basically, you have the Genlayer chain. You can see right now it says protocol architecture, yeah?
Yep.
Yeah. So there's the Genlayer chain. The Genlayer chain is a ZK rollup, right? So that's basically taking care of the ordering of events, of the prevention of those spend, all the things that we're used to on the transactional level, right? But then there's this overlayer, which is these 1,000 validators, each one of them connected to a different LLM, each one of them connected to a different website potentially, right? Like they can be doing things independently. But then when they are when they're evaluating the transactions are going through the consensus, which is a smart contract on the chain, right? So there's a smart contract on the chain, which is the consensus, and then a transaction goes into the chain, gets processed by the consensus, selects which are the validators that should be part of that transaction, and then each validator will run the Gen VM, which is a WASM execution environment that can basically, you write the programs in Python, can go to, an LLM, can go to the internet, whatever they need to do, right?
Okay.
Yeah. So essentially, look, I think that this is a good visualization of this. If you go, I'm happy to share this link as well, right? So basically, this is how it looks.
I will share them all.
Yeah. Ooh. So you've got basically, imagine that each one of these guys is a node. This is just a simulator.
I actually can't see anything.
You can't see anything.
It just looks like a grid.
Yeah. So imagine this is a validator, this is another one.
Oh,
so
okay.
When you're doing a transaction, we can even say like, okay, whatever. Let's say that 10% of them are malicious, right? That's more beautiful, more pretty. So then you say, okay, there's a new transaction coming in, right? Then from all the validators, right? There's basically 5 that are selected. One of them is the leader. And then the other guys are the validators, right? So there's 4 validators, which is 5 with the leader itself and then the leader, right? Now, in this case, for example, well, it picked one of the malicious, right? And then 3 of the 5, which were normal validators, right? So in a case like this, maybe you're the user, maybe you're happy enough with this, right? But maybe you're moving a lot of money, right? So maybe somebody else doesn't agree with this, or who knows, right? So if you appeal, what's going to happen then is that, well, double the validator set, now it's 11, right? So 2n plus 1 are selected as well as at random, right? So the idea here is that the more validators that you're bringing into the mix, assuming a majority honest validator set, right? What's happening is that the more validators that you're bringing, the closer you're getting to correct response, right? The goal here is like, what Genlayer is if Bitcoin is trustless money and Ethereum is trustless applications, Genlayer is trustless decision making. Now, how do you make decisions between intelligent entities, right? There's a lot of different types of voting systems. What we've done is found one that we think is best for the type of infrastructure that we're working on, right? Given the constraints that LLMs are expensive, that there's networking, that anybody can run their own systems, and we don't want to be able to focus on the verification of the inference. What we want is, imagine that one of these guys is a monkey. It should be able to participate as well, right? Now, the way that this essentially works with the crypto economics behind is that there's an incentive for people to basically be running better models simply because like this they will make more money, right? So
So why would we make more money?
Depends on the questions that you're asking them, right? What's happening right now is, let's maybe simplify this for a second, right? If you're asking somebody, if you're asking a judge, for example, to make a decision, right? You know that this judge can be right or wrong, right? Depends on the question, right? If I tell you what time is it, you can look very easily. If I tell you, who's the president of the US is another thing, but where are you going to be looking at? Could you be wrong, right? That's maybe 90-something%, let's say, right? If I'm telling you to make, is UBI good or bad? It's something, very, very, very subjective right now, right? So there's a degree of correctness that depends on the biases, on the knowledge, on the quality of the model. One thing we're for sure is that the cost of LLMs is dropping, right? Very, very, very quickly. As a matter of fact, right now it's cheaper to run a more intelligent LLM than an old one, right? Because all the infrastructure is being optimized for the new LLMs, right? The cost of inference is dropping very, very, very quickly.
Right.
The cost of intelligence is increasing, like the intelligence itself is increasing very, very quickly, right? But ultimately, depending on the questions that you make to these LLMs, right, it can be that they're more or less correct. For example, I'll give you an example because I think we can take this conversation however you want, but there's quite a few things, right? So I feel like it's kind of difficult for people to follow without really understanding the type of applications that we're talking, right? So maybe I'll stop for a second and show you that, right? What we're talking here is a decentralized protocol that can make intelligent decisions without any human in the loop, right? And because of that, because these decisions are subjective, because of that, it can go to the internet. And because of that, it can, for example, go to an LLM or do floating point operations, right? Make non-deterministic operations, right? All blockchains are fully deterministic. Genlayer is a layer that allows these blockchains to make subjective decisions, right? To make non-deterministic operations, right? So to see some examples, if you want, like there's this thing, there's prediction markets right now, right? So prediction markets are going to DAOs of humans to make resolution of certain events happen, right? Extremely slow, extremely expensive. Imagine if instead of having a DAO of humans, it was a bunch of LLMs that just reach consensus. This is what Genlayer is, right? So it basically means that you have insurance, insurance, perpetuals, different type of options, different type of, prediction markets on basically anything. It means that you can make, for example, a game where the game master is the protocol itself. You can make a decentralized financial protocol where basically the community can be saying, hey, you need to stop because you're getting hacked. The decision of stopping the protocol shouldn't be laying down on anyone's hands, but actually the protocol itself. Right? A DAO that can make its own decisions without any external entity, right? Just the DAO itself can go to snapshots, see what's going on and say, okay, I need to vote the best weighted, I need to follow the rules of the DAO, right? And then make a decision that is correct and at the same time, say, for example, is legal, right? How do you evaluate if something is legal or not, right? So that's what the DAOs can do. You can basically have, well, again, where are you making decisions? Now you can delegate the decision-making to Genlayer and then no one is making the decision. There's just a bunch of AIs making those decisions. And it's very important how correct these decisions are, right? So the way that we do this is basically instead of getting a single LLM and say, hey, LLM, I trust you, and just like give me the answer to this, well, it can be that these LLMs are very powerful, but right now they, let's say that you ask them something very easy to do, who's the president of the US right now? I want you to find where you can find it and then go find it, for example, right? So that still would be pretty high, I think. The problem is that 96% is not enough to do DeFi. If you want to do DeFi, you need 100%, right? So if 96% is a single validator, if you now do five, it's going to be 99%. If then you appeal and you bring even more validators to the mix, now you're basically 100%, right? That's
Well, I
the difference.
guess so.
Yeah.
So I guess on the how you incentivize this would be like you reward the median hire would be.
Well, the way it's happening is I mean, the ones that are rewarded are the ones that are in the majority vote,
Okay.
right? So,
Yep.
yeah. So what's happening here, if we go back to the simulator, right? Just let's keep it simple for now,
So
right? So
if you go the opposite direction of other people,
yes, you'll be penalized, right?
you're
But
penalized or
well,
just
you're
you don't get
penalized.
rewards.
You'll be slightly penalized, like
Okay.
well, you want people to be able to make money from this. You don't want people to be lazy either, right? So there's a commit and reveal phase so that people don't know what is actually being voted, right?
Yep.
But at the same time, there's a slight penalty, so you want people to actually be doing the work, right? Think about how humans organize themselves, right? It's very easy to say, yeah,
Yeah, no,
okay,
I mean this is like all oracles have this problem too. It's the called the mirroring problem where people are
right.
if you see somebody else submitting a transaction, you don't want to just submit it. But this was part of my question on the how do you get them to run different AIs?
Mhm.
Like wouldn't they all be incentivized to collude off chain and run the exact same one so that they know they're all going to be in the majority?
Well, I mean, there is an honest majority assumption, like
Yep.
basically on pretty much every decentralized protocol right now. The thing is, the AI right now, like, right, there's so many models and there's new models every single day, right? With time, what will happen is like this. You can choose to work with others, but you can also choose to have your own cache. You can have, for example, a system that tells you, okay, this transaction is very simple. I can go to a dumb model, or this transaction is very, expensive, let's say, and I want to go to the best model to make sure that I've been picked as the leader for this transaction. I'm going to make money if I am on the winning side of this. But I will only be on the winning side of this if the majority of the network agrees with me. Now, the majority of the network wants to disagree with me, right? Because like this, they can have an incentive, but it will be only essentially there's the selling point on truth, right? It's like, okay, I know that everybody will be able to verify that information and that they want to go against me in a way because they want more money, right? So what's happening is that everybody is going to be voting blindly. They know that there's a proposal, right? They can see the code, of course, right? They can run it, they can test what's happening, right? But ultimately, they all have the incentive to arrive to truth because on top of this, like that's where as well, like the DPoS matters, right? They all have a stake. They have been selected because of they having a stake, right? So, um,
Well,
yeah,
sure,
I
but
mean,
I think
yeah,
like you let's say we're all running the old models and then DeepSeek comes
yeah,
out. Like,
hmm which is cheaper,
would I
right?
be incentivized to do DeepSeek because it's
I mean,
cheaper? Or
immediately,
like
right?
would I be like there might be like a little bit of a delay because like I wouldn't want to because even if because like this is like a lot of times like with prediction markets and non-determinism, like if you're penalizing the losers, what you might be doing is penalizing dissenting opinions. So like,
Hmm.
like you would say like, if you ask the UBI question, the person might be it might be the right answer, but it might just not be the most popular answer. And so like
Well,
are you
it's about this. So if you look into
yeah,
what the Condor set is telling you, right? It's what is the question, right? If the
yeah,
question is basically if the average of the network is more than 50% to agree, then that will go to 100%.
yep,
The question is the question that this specific validator got, right? Is it a question that is consensual, right? That can be reached
yeah,
consensus on, right, or not, right? Of course, like the more far away it is from 50%, right? The better, because it very very fast trends towards the 100%,
yep,
right? So what you're saying in this case is like, yes, we're not trying to say that on Genlayer will have the best model the day that they come out. To be honest, R1 is way cheaper than OpenAI, which means that yes, The problem in a way, is that there would be a lot of incentive of going to R1 simply because it's cheaper,
Yep.
right? But then you're moving from, okay, I'm just too lazy to actually choose to change to R1, and at the same time you're arguing for the opposite. So like all those essentially balance out. The way we look at it is like there's going to be so many different models that over time every single one of the validators will be running different model, because there's just so much, for example, you can do some, small pre-trained model just for that specific contract, right? So you have seen that contract before so many times that you can just pre-train a small model just for that specific contract to give the best and cheapest answer that is correct, right? It's not about using the best model. It's about getting the best response given that, cost. It needs to be, yeah, it needs to be performant, needs to be correct. It doesn't need to be the best, right? Most of these questions, if the majority of the network is already like 95%, you probably don't need the GPT-6,
Well,
right?
like, do you
Because
have to on another like if I'm selected as one of the five or selected as the composer, do I have
yeah,
to answer the question?
yes,
Because like
yes.
okay, because like that would be because I feel like there would be almost like if it was a 50-50 answer, like the UBI question, it's just a poorly formed question or something like that. Like it's probably in my interest not to answer this question, right? Like,
I mean, you have different things you can do, right? I mean,
okay,
and
what, yeah,
yeah, when I'm saying penalize, like this is just like it's super, super, super minimal so think of it like this, right? It's to the point of you can't even make sure that somebody hasn't created some trick smart contract, intelligent contract to basically try to trick the system, right? So it cannot be an actual negative, right? It's just enough so that it basically doesn't make sense to be lazy and just quotes agree always, right?
okay,
That's the thing, right? So, but ultimately, like, it's a very difficult calculation because you have that the cost of inference is dropping, the intelligence is increasing, right? The cost of detecting, like, whether something should be appealed or not successfully is dropping as well, right? And the correctness of that is increasing too, right? Yeah, I mean, yes, it is a very poorly formed question, right? If you're looking at, for example, a prediction market and you say, okay, let's see, let's go to find some, like, yeah, what's the weather right now in Dubai, right? So each one of them, they can go to a different website. Each one of them, they can get a different response. That's not going to be 50-50. It's going to be whatever, 80, 90%, right? Those are the normal situations, right? For sure, some contracts that like are poorly formed and they define something that is very subjective, right? Yes, that's going to be much harder, but ultimately you will get an answer. You will get an answer on whether the majority of the network agrees or no on A or B. Yes, for or against on like, let's say 1,000 validators, if you did all the appeals, right? And that's very valuable information, right? Because it means that it's more than 50%. You can actually know from all these different validators what was the correctness of that specific question. You see? How many did it take for you to actually get a resolution? We're going really deep into the game theory here. But
no, no, this is I so
yeah,
like
I'm happy to.
it's very similar. So I actually had on I had Micah Zoltu and Edmund Edgar. This was like 6 months ago now. But they work on prediction markets. And so we were going over like the augur game theory from back in the day where it's like how do you handle all of the bribes and things like that. So it's you're still sharing, but
Yes,
yeah,
I'm sharing. I know,
okay,
I know.
cool.
I'm open. So we've got this framework called the Intelligent Oracle. This is under MIT, right? So anybody can come and pick it up. I would suggest you guys pick it up, and it can be a sub-product, I guess, right? But basically, what this is doing is, look, for example, right? This is what it takes to do this. There's an agent that helps you define the spec of an oracle. You're just chatting with the agent, right? ChatGPT, right? And then you say, okay, I want to do, for example, a flight insurance or flight prediction market on like whether it will be safe or not to fly to Iran on a specific date, right? And then what's happening is that the different validators are going to this specific website, right? And then making a decision on whether you should be traveling or not to that specific location, right? You can make it so that you're specifying exactly the website, or for example, the user can provide the website, or for example, that the contract. So each one of the validators are figuring out where to do it, and then going and fetching the information, right? Of course, if I'm telling you exactly the website, it's going to be way more correct than if I'm telling you, go figure out which is the website and then come back, right? Because that requires some more thinking, planning, and so on, right? So What I'm saying is like basically Genlayer allows for this type of use cases, but many, many more where you have different degrees of subjectivity, right? Non-determinism, and that's the beauty of it. It's like we need some new tools that are just like right now not possible given existing infrastructure, right? And they enable new things. Like for example, for me, Teller could perfectly connect to the intelligent oracle to basically have specialized oracles on specific, points of information, right? Because why? Somebody still needs to write this contract that needs to define, okay, I think that these are the correct data sources where you could go and then make the resolution like this, right? We're not here, for example, to compete with Teller. We're basically infrastructure that allows Teller to then say, okay, I can have this set of intelligent contracts that are essentially the specs of different oracles, and then they can execute and do this with infrastructure that you've already built, right? Like a different data source, basically.
Sure. Yeah, no, I like it. Anyway, no, this is really, really good stuff. I think, yeah. So I guess we can kind of loop back and then we'll start talking about Redley again. Before I go deep down the appeals rabbit hole. And, I mean, first off, there is a fee to appeal, correct?
There's a bond to appeal.
Okay, bond.
And then there's a bond to appeal, right? And then I mean there's the gas fees and stuff like that. But yeah.
So
Ultimately, it's like the user defines how the user as well as the application developer itself define how safe it should be in a way, right? So like depends on yeah, you can say basically, I think that given this specific application, the developer can think, okay, this is how correct the system it should be, right? So I'm estimating that there's going to be this many number of rotations of leader and potentially appeals, and I'm going to be pre-funding some of it to make sure that there's an incentive for people to come in, post the bond, and then appeal, right? So
yep.
it's a system where again, it's very, very, very much like the traditional court system. Just instead of having a single judge, you have a bunch of them, right?
Yeah, no, that works. Would you say it's similar to like, would you call this like an enshrined oracle in a way?
Would you describe that? How would you describe that?
Well, I mean, like the val so like this has been a debate in Ethereum land for a long time. Do we want to enshrine oracles? Now most of Cosmos is doing a lot of enshrining of the oracles where like the validators themselves, they'll say like, you guys have to go bring in the ETH price as well. So you guys got to post an ETH price with every single block. And then the ETH price oracle is now enshrined as far as like you don't need external oracles.
But that's deterministic, right? So like they need to deterministically every single time do that. Yeah.
Well, it's basically I would say like the what enshrining would imply is that like you're willing to fork the chain
Over that.
over the consensus of this. You know what I
Yeah.
mean?
Nothing to do with that. No, no. So in this case, like that's what I mean. Like it needs to
Yeah.
be what you're describing is essentially deterministic, right? Like every X number of blocks or something, they need like the validators need to go do something and then come back and then it's fixed. Here it's not the case, right? It's like this is just how do you make trustless decisions. And then there will be a decision. You can agree or disagree. If you disagree, you can appeal. And if you appeal sufficient times and you're still wrong, then you're still wrong, right?
Yes,
So
and you sort of just admit it. Listen,
yeah,
if the AI is wrong on this question, it's just wrong on your question.
exactly.
You
Maybe
shouldn't
you
have
did the wrong
yeah.
question. Maybe the data source is incorrect. Maybe the AI is not smart enough, right? It
Yep.
can perfectly be. Like you can make it so that, like to the point of where you can have an intelligent contract that is capable of going to the LLM, ask the LLM to write some code, and then execute that code on the fly in the middle of the transaction, right? So it is very much non-deterministic, right? And that's the thing that the biggest difference here is like, how do you make a consensus that is non-deterministic,
Yep.
right? Now, the game is deterministic, but the actual outputs are very much not deterministic, right?
But this one, what I found interesting in your model is that is the validation of the chain is almost separate from the validation of each individual contract, correct? So like
Yes.
you almost like because like this is one of the big issues with like enshrining oracles in like your chain is like if there's an appeal process, you basically have to halt your chain while you figure it out
Right.
because like DYDX for instance does it where they'll enshrine the price oracle, but you sort of need it enshrined because like if there's a giant price move, like a bunch of liquidations happen. So like you kind of don't want to continue with the chain. But you guys like would silo out a contract and say like this contract.
It would be on a contract basis. So there's
Yep.
total ordering on a specific contract, right? And if there's an appeal that was successful, then the other transactions would be recalculated for that specific contract, not for the rest, right?
Yep.
So yeah, yeah.
So then does your consensus engine like not then allow interoperability with that contract that's not finalized?
It depends on the developer.
Okay.
Right? So you can choose, for example, imagine that you have a game, right? Maybe you don't care if the game, like the state is not really, there's different ways that you can do this, right? But if you were to do, let's say, a totally natural language based AMM, right? Yes, I wouldn't ideally do it on Genlayer alone, right? Like on the non-deterministic. So like Genlayer, these intelligent contracts, right? You write them in Python, right?
Okay.
Now this Python is being run on a totally deterministic execution environment that is capable of spinning up a non-deterministic execution environment, right?
Yep.
So you can write an AMM totally deterministic on the layer, and then the transaction will be fast. There's no appeal because it's fully deterministic, right? Like you can just do like some deterministic violation, and then you would be seriously slashed, right? But it's all that you can do. For the rest, it's just going to be going normal, like a normal smart contract, right? Now, if you want to do the non-deterministic operations, then is where really like the consensus kicks in, because then you have, well, each one of the validators will have their own output, then they need to have the voting, then you need to have the appeal window. And the appeal window is going to be about 30 minutes,
Okay.
right? So yeah, I think that the developers need to understand, whether what they're trying to do is, can you just do it deterministically? Can you do it with, like a mix? Like, does it make sense to do an AMM that is fully non-deterministic? You can do also like a token that is just with natural language. It's just
Well,
not
well, like it's the same like if you're writing a perp dex over here and
right.
you're using this as the price oracle and
Mhm.
there's a disagreement, like you wouldn't be able to withdraw your tokens
It
from
depends. That's what I mean. It depends on
yeah.
the developer, right?
Like if
If you're
you're
the
really
developer, you
YOLOing
can
it.
say it needs to be no. You can say like it's a different tool, right? And that's the thing. We're not trying to compete with oracles. Like we know that there's better infrastructure for price feeds, for example, right? We know at the same time that we are trying to build the infrastructure to do like be able to connect to anything in the internet, right? And go fetch any information, right? So like while Oracle, like you would expect like super performance streaming of information in a way, here you can just go and fetch whatever information you want. There's no need, for example, for zk-TLS and stuff like that, because then you have basically like you can even go to different websites, right? So trying to decentralize the decision making rather than just focusing on, like on one of the points. Um,
Yeah, I mean it's really tough whenever you have to like I'm curious to see what gets built there because, like pushing a lot, it seems like a lot of these decisions are being pushed to the app developers. So like it'll be, like
It's complex.
yeah.
It is. You have to understand. You have to understand what blockchains are. You have to understand what AI is, right? You have to understand how the consensus works, right?
So
To a
there's
degree,
like three people, right? It's
right? Yeah, but like,
yeah.
yeah,
It's
it's good that we have AI, right? So like AI will be writing most of the code very soon. So it's not going to be quite lazy or it's not going to be too burdened by that, right? To figure out how to actually make sense of it, right?
Yeah. Well, I mean, like, would you say like would you recommend most of these contracts? Because this was something that we had gotten into in the prediction market space. It's like just due to bribes and due to other kind of flaws in these dispute systems, like, a Schelling point design, a basic one, like they're not necessarily as secure as you would hope. So like even blockchains in general. So you always have like this backstop of forking, right? Like even if the crypto economics gets captured, we can always like appeal to humans. Like we always like we have the ability to just not accept the answer of the chain. Like even if, like if 90% of ETH validators are captured, it doesn't really matter. We're just not following that chain. Um, would you recommend a lot of these app developers put like almost like DAO based governance over top of some of these contracts, or you have some ability to fork over top, or
I
no?
don't think, personally, I don't think that makes sense.
No?
I think that we're in the age of AI, and AI will not want to wait for days. It will just be like instant decision making. will be more or less correct. For some applications will be good. For some other applications will not be good, right? I would rather just focus on, I want to essentially, create a network that is capable of advance with AI. The better AI will become, the better the network will become, the more type of things it will be able to do. And sure, we need to find, how to make the economics work so that there's, aligned incentives, right? But we're actually feeling pretty good about this. I think, there's lots will change, no doubt in my mind, right? But the goal is super, super clear. Like, assuming that it's people, how do people organize themselves? We humans have not, found the best way to do that, right? So we're proposing a way that we think is good enough given the constraints of the system, right? Again, like the LLMs are expensive. There's different ways that you can do voting in a way that is even more correct. For example, with even more duplication, right? You could basically have every single validator come up with a response, and then with tuples, for example, compare between themselves, right? Like it's another type, but that would be extremely expensive, right? Ultimately, it's like depending on the use case will be, in a way, the only way to do it. Depending on the use case, maybe it will not be, interesting to do it like that, or it will not be even feasible, right? And I think that that's what we want to see. The goal is, look, we have seen what you can do on blockchains. We have seen it, right? Uniswap, Aave, synthetics, all these things came out years ago. Years ago, we saw how, having oracles essentially enabled endless new types of applications. Now, we need to essentially have new infrastructure that allows to do new things and see what people can build with them, right? And this is what we're here to do. Like, we just want, new primitives to be built that are permissionless and trustless, right? And that's that. I think that we will do very well, to be honest. Yeah, ultimately, like, it's fascinating how AI can, like, natural language is way more powerful than code. And this is what we're seeing right now, right? It's like right now it's the moment where you see that the cost of inference is falling like a rock. You can do things, say, for example, is this proposal from the DAO legal or not? You can't code that. It's impossible for you to code that, right? So
But like,
opening
how do
up,
you?
yeah.
Yeah, I mean, like a lot of it though, like it's very nuanced, like is this legal? Like we have
Yeah.
it's not it's not a black and white answer. Like
Is
this
that,
this
yeah,
is
I understand. That's the whole point. That's the
yeah,
whole point. That
like
is literally like on the deck, we literally have like the world is not black and white.
right,
Why are we just constraining ourselves to protocols that are just expecting black and white? The world is not deterministic.
right.
Natural language, yes, it's ambiguous, right? Natural language is powerful because it's ambiguous, right? You can't you take 100-page, like legal agreement, you can't codify that because there's lots of ambiguity there, right? But somebody needs to make those decisions. How are we making those decisions right now? We're relying on humans, but humans are expensive and slow, right? Can we use AI to basically make decisions in at scale, right? But they need to be trustless. It can't be that there's a single, inference provider or a single model that has specific biases that are making those decisions,
Well, this
right? We need
is yeah.
infrastructure. Yeah.
I mean, like correct me if I'm wrong. Would you say that like most of these blockchain networks, like now we'll get into the philosophy of it, I guess you could say, like, would you say like most of them, like probably the goal of say these networks, it's like coordinating and figuring out almost distributions of non-blockchain assets, right? Like the whole goal of these legal type system, decentralized legal systems is ideally for some purpose other than just moving around bits, right? It has a real world connection. So like kind of like I was talking about before, one of the reasons that it seems like the mentality of code is law is breaking down, right? Like the idea of code is law on Ethereum, like maybe some Bitcoin maxis will still push code is law, but like the vast majority of us are like, no, code is not law. Like law is law with like real people. And like these are just little tools and the intent and a lot of these things matter. So like, like
I
where,
mean, yeah, you're totally right. We're going into the philosophy, right?
yep,
So you're saying code is not law. Okay. Why is it not law? Because there's nuance.
yep,
Okay. You're saying code is not law because there's nuance. And we're assuming that only things that can understand nuance is humans, right? But I think that this is something that's breaking apart as we speak, right? We now understand that we have, or we will have, AI that will be as smart and smarter than us, right? So, okay, if code is really not law because there's nuance, but then you can use AI to essentially evaluate that, well, this is how you do it, right? This like you need a way for making those decisions. Who's hosting that? Do you put that in AWS? Do you put that? Do you trust OpenAI to make those decisions, right?
No, I would
I
say
think
like
you don't.
I would say the actual argument would be like it's almost like you need the humans to agree with it. You know what I mean? Like you need like it's more like are we at the point where humans will accept this as an answer for distributions and for legal? You know, like we always like go to like a jury of your peers or you have an appeal to some, you know, like human element even from contracts because like we agree like legally written contracts can be ambiguous. So we have like there's this sense of justice that comes from having an actual human look at it. But like if you go from like, is there a sense of justice for the people involved to have an AI look at it for your court system? You know what I mean? Like I feel like just people aren't there yet. It's not a knock on
No,
like AI is not
I
moral.
agree with that. I think that humans will have a very hard time to understand what's coming.
Yes.
But I think we're going to a world with 100 billion agents and 8 billion people. So I think that most of the commerce will not be done by humans and will simply be done between agents, right? So for example, one of the use cases that we're working on is imagine that you have, you know, let's say open source software, right? How do you define who has been contributing how much? How can you pay the people for their contributions, right? Maybe you don't know who they are. Are you going to be reviewing everything? How do you know that there's no, like bug or stuff like that in there, right? Like, some backdoor, for example, right? Can you create a contract that is automatically, like autonomously capable of understanding the contributions from the developers and then evaluating, giving it a score, and then paying for their job, right? That you can completely do on Genlayer. You can have an intelligent contract that's paying people for what they did, their contributions on code, or their contributions on social media, anything you want. No human in the loop. You don't want a single entity to make those decisions. You don't want to trust who's going to be taking that risk. Who do you want to trust for taking that money and making those distributions, right?
Yeah.
Isn't that what your shop is doing? Like you just have, okay, now you have a bit of code that is capable of taking in money and then allowing for exchange from one to the other, right? Now you can make that way more complex and enable new things that you just can't do anywhere else, like this I just described.
Yeah. No, I agree. I think that's I find the thinking very, very interesting, especially along the lines like I'd seen you say before, like, you know, basically like all of software will be gone, right? Like
All of it.
software is going to be eaten. And it's this very like AI centric view of moving towards it. But I think it is sort of the question more so like after if you assume that as true, the question is like, do we want that? You know, like as humans in the loop, like if there's a billion agents doing things, like do we want to jump into this world feet first? And like what are the risks of doing so?
Can we do anything about it?
That's a different question, I think, right? Like I
Yeah,
think that, well, I think
fair.
there's a different question of like, you know, like kind of like, listen, AI robots are going to nuke us. Let's go build them the nuke. That's like different, you know what I mean? Like you don't necessarily have
I
to.
know. Look, my wife, she's very, 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 yeah, her PDUM is much higher than mine, let's say,
Sure.
right? And so we have this argument all the time. To me, we're in this step change right now. We are at the bottom of the stair, and our babies will be at the top. We're right in that moment. This decade, basically, all of this is going to be changing, and like we cannot do anything to change it. So like you might as well like, just embrace it and think, okay, what are the things that I think will remain true at the top of the stair? I think that at the other side of this event horizon, trust will be needed still,
Yes.
right? So there's always going to be a way to basically do my AIs trust your AIs or not, right? Or even if there's no one's AIs, doesn't matter, right? Are they going to be trusting each other blindlessly? Of course not. They will be reading the fine print. They will be checking the code to make sure that there's no bugs in the code. They will try to see the best possible way to whatever they want to do. And if that's the case, then I think that there will be a need for basically having a jurisdiction where they can be playing in a way that is, not up to anyone else, right? I mean, we've done this with Bitcoin and Ethereum for many years, but like our types of applications are very simple, are deterministic, just like brutal, like simple logic, right? I think that they will enable tons of new things, and they will need it. It will not be possible to do on traditional law. It's just too expensive, too slow. We're talking millions of dollars, years to resolve a conflict, right? And if you're going with humans too, like okay, like if it takes, let's say, 48 hours and $5,000 to make a resolution, right? That's eternity and extremely expensive. Now you can have prediction markets that get resolved in a dollar, 30 minutes final,
But
right?
would you say that blockchains are the correct way? Because like ideally you see this AI rush coming, and we would want to decentralize it, right? So hopefully make it so not one company controls it. That would probably be the goal, I guess, of a Genlayer type system.
Genlayer is more like how you make the decision making decentralized.
Right. So like how do
Yeah.
you, but
So
like,
like,
yeah.
yeah, there's going to be many companies doing these AIs, right? And each one of them, they
Yep.
will have their own biases and their own like sneaky things, right? How do you try to remove as much of that as possible when you're making a decision, right? And it will be useful for blockchains to make decisions. It will be also useful for non-blockchain actors to actually make decisions, having that they have a court system that can make a decision without any one of them being biased, right? So it actually enables quite a lot of things, and it's not going to be the best AI. It's just going to be one that is trustless.
Yeah. Well, I
Right?
mean, you have like some people on like the argument on like the pro tech left would be like, they've talked about like having like open data repositories, and you have like the government run AI themselves, and you have more of
Right.
like a centralized one, and this would be more on the decentralized piece. But like with like the argument you could make against a blockchain-based system would be like we don't necessarily have the greatest track record with not centralizing our validator sets, right? Like Bitcoin got centralized, Ethereum has its own like LST centralization issues, especially like Coinbase. Like how do you think this will play out? Like do you think this will also be centralizing in some ways, or like do we just have to, is that maybe the human piece here where we have to like fight that validator centralization in some way?
At the end of the day, is like who has the resources, right? And who has,
Yeah.
it's quite interesting because in the Genlayer model, like the stake is actual power, right? Because the leader makes a decision and then the other guys have to vote on the decision. But that's the same as in the normal world, right? The
Right.
president makes a decision. You voted the president. The president has huge power. Now, here it's happening on a single transaction by transaction basis, right? There's a transaction, there's a leader, the leader makes a proposal, as long as it doesn't, create something that doesn't fall through, let's say, the filter of the validator function, then it's accepted, right? So it has a lot of power, right? I think that as people will understand, as we will see as well, more applications being used, right, that are using this type of decision making, I would hope that the stake will, follow accordingly because that power actually matters, right? It's not just about, ordering of the transactions. It is actually about making decisions, right? And those decisions can be very important if you're managing, for example, a DAO, right? If you're
Sure.
making, yeah. So I think that it's important to do the intelligent contracts well so that you're trying to be as narrow as you can on what is acceptable or not, right? Because at the end of the day, you need to understand there's going to be a leader that will be selected at random. You shouldn't be trusting the leader. You should make a validator function, like the equivalency principle. What we call it the equivalency principle. It's like the filter, right? This acceptance threshold that is as narrow as possible because assuming that the leader is a bad boy, you can still accept his or hers output, right? Its output, right? So yeah, ultimately it's just let's try some things that are new, right? It's just like
I
I'm
love that though. Yeah.
kind of bored of the same old stuff, like it's just copy paste and forex and stuff is very difficult, and so I'm sure that we will see tons of new things here, and I'm really looking forward to see what the community will come up with, because I'm sure there's going to be things that I haven't like. We like the Hitchhiker's Guide to the Galaxy. Like there's this infinite improbability drive. There's this big button in the ship, like they press and then it turns into a, whatever, a sofa and then a whale and so on. It's essentially telling you like everything will be possible here, right? It's gonna take you very far, but you don't know what can happen there. It's just really, 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 a fundamental change in how you do things, right? And so we're really looking forward to that, to see what is possible in it. Yeah.
Yeah, no, I am too. Did I miss anything? Like what would be like any big pieces that I like left out? Are you guys, what's the timeline, I guess would be one question for you guys.
So we would like to get the protocol out as soon as possible, of course, right? So we're already in like internal testnet, starting next month to onboard external validators as well. We want people to come in and try things. There's some of them that are like to us like very clear low hanging fruits that I think like, let's say for example the intelligent oracle, right? I think that anybody can come in and use this already today, at least, maybe it would be like a testnet style right now, but like, hopefully in the next few months it's just gonna come out from testnet and then it's gonna enable basically prediction market insurance on basically anything, right? We've got people working on, futarchic systems, for example, right? So that's another type of prediction market as well, right? A bit more subjective, right? So you can essentially, yeah, I don't know. The original idea for Genlayer is how can we create a trustless protocol that it can essentially users can send it information and the protocol can verify that information and structure it, right? So for example, if you want to create some Wikipedia that it's not managed by anyone, but actually it's just the protocol is organizing the Wikipedia, this is how you can do it, right? We've got these other guys working on, some Fraser style game, which is like, like the game master is a protocol. People are betting against, trying to beat the protocol in a way, right? So I
Super
don't know,
fun.
just looking forward to it. It's gonna be fun.
Yeah, no, I'm gonna come play around. It'll be good. So yeah, this was a blast. Anyway, where can people find out more? Where can they
Yeah.
play around?
Join our social, like, on the socials. So at Genlayer, come to our Telegram group, Twitter, Discord, everything. Feel free to reach out. Yeah, you can try that right away. So like just studio.genlayer.com and you can already try it live. And then it's the testnet, but you can try it. And then we're trying to have as much documentation as we can so that it's actually easy to work with, right? And then I would encourage like just we've got this button at the top called bulk download, and you just copy that into ChatGPT and just ask write this thing for me and try something. It's actually quite interesting. Um, Weird times we're living in. So
For
yeah,
sure. Yeah, can't agree more. Anyway, thank you, Albert. Come on.
thanks. Talk soon.